Hi, this is my lab. So in this lab, we're going to be investigating projectile motion by using both experimental and computational models. The key principles is pretty much we're going to be using Newton's second law, the momentum principle, and drag proportional to velocity squared. And pretty much the main result of this lab is it showed that the model, including drag, was a lot closer to reality than the gravity-only computational model. Important formulas we'll be using is drag force is equal to negative b v squared times vector v. Force of gravity equals mass times gravity, and net force equals force of gravity plus drag force. The object we used was a paper ball. We recorded on our phone using used a tracker to analyze it. We used a white for us. We went outside in the hallway. We kind of used a ruler to show the x-axis along the floor. The system in this experiment is the crumpled up paper ball. The surrounding is earth and the gravity force that's exerted on the paper. Initial conditions are x0, y0, initial velocity equals 0, and mass is 6.73 grams.
6.7?
So this was our experimental data. On GlowScript, this is what everything looked like. Velocity versus time was constant, position versus time. With drag, this is a much better representation. It showed how, compared to this graph, it showed how, you know how the graph, you can see how the graphs are a little different. This showed more with air resistance and how a realistic depiction would be. This is the code. F-drag, again, this is the drag force equation. So comparison, experimental trajectory matches experimental model with drag much better than the experimental model without drag. The model without drag overpredicts the height and distance. So it shows like for how light objects, how drag has a good, like a large impact on it. So what if our object were initially thrown straight up with the same speed?
Bro, Josh, shut up.
Would the object take...
Wrap it up.
Shut up!
That was fine.
Would the object take longer, shorter, or the same than your original experiment? So all the speed is vertical, so it rises higher and it takes longer time to fall back down. But in an angle throw, only part of the speed goes upwards, so the object spends less time in the air. This just means that terminal velocity happens when a freely falling object experiences zero net force. Some possible sources of error would be video recording issues. The camera recording the video could have been a little better. There was scale calibration errors, so like if the ruler was placed incorrectly, and then there's a programming error as well. The main idea we got from this is that projectile motions require considering drag for realistic predictions, and the experimental model fit better with the computational model with drag than without. How do I stop this? How do I stop this?